Hi, future doctors. Welcome to the next class. In this class, we'll see equilibrium. Equilibrium of rigid body. So, what is meant by equilibrium means in laws of motion we discussed. When net force is going to be zero, then object is said to be in equilibrium. If you want to say rotational equilibrium of rigid body, so you require sum of forces should be equal to 0, and in addition to that algebraic sum of torques are also going to become 0. If net force F1 bar plus F2 bar plus and so on Fn bar, if n number of forces are acting, so torque means tau 1 bar, tau 2 bar and so on tau n bar is going to become 0. So then we can say object is said to be in equilibrium condition. Next, how we are going to take these in problems, we will see. So, principle of moments. Any object which is placed, this is called fulcrum, at a distance d1 from one end, another distance d2 from another end. Seesaw we will be having. Small kids are going to play by sitting here. So one force is acting like this F1, another force is going to be acting like this F2. Isn't it? Now, how resultant torque, resultant force is going to become 0? Is this in equilibrium condition or not? How we are going to apply means this fulcrum is going to apply reactant force or normal force in upward direction. Like any object of mass m, its weight is going to act downwards, normal reaction is going to act upwards. Correct? Same like that. Therefore, upward forces R is equal to F1 plus F2. If we have taken two fulcrums here, then R1 plus R2 or N1 plus N2 equal to downward how many forces are going to act. I am taking mass of this object is negligible. At the time we don't want mass of this rod or object. So upward forces equal to downward forces. So this is going to be this one. Next, what about this one? That is going to be important. So this force at a distance d1 is going to produce clockwise or anti-clockwise, you can see. So this is going to produce anti-clockwise. This force is going to produce clockwise. So right side it will be rotating like this. This is going to be clockwise. Left side it will be rotating like this. Therefore, this is going to be anti-clockwise. Always anti-clockwise you will take it as positive, clockwise you will take it as negative. So if you wanted to go outside of the room or you wanted to go for any vacation, so for room you have to lock. So that lock how you will rotate means anti-clockwise. If you want to go outside you have to lock it, otherwise you cannot go by leaving. If it is not coming means no problem, you will break that lock, but if it is not locked means you cannot go outside of the home. Therefore anti-clockwise should be positive. If you switch on your ceiling fan, and did you observe in which rotation, clockwise or anti-clockwise, your ceiling fan? Your ceiling fan will be rotated anti-clockwise. Today you can see by switching on TV means uh, fan, it will be rotating anti-clockwise. Its direction, so ceiling fan will be horizontally like this. So its direction, it will be coming downwards towards you people. So along the axis of rotation, angular velocity is going to be present. If you want to rotate the tap will be rotating like this. That is also anti-clockwise. To close, you will rotate clockwise. So anti-clockwise should be positive thing for us. Therefore anti-clockwise, if it is rotating means that one should be positive. Blindly we can follow. Clockwise means that one you can take it as negative. So what is the torque definition? Torque is nothing but force into perpendicular distance. This is nothing but torque definition. Now torque for this one, force perpendicular distance d1. Therefore, F1 d1. Is it positive or negative? Means it is producing anti-clockwise, therefore positive. Next, tau 2. So F2 d2. It is producing clockwise, therefore it should be negative. So sum of torque should be equal to 0. This is also same. Upward forces, downward force we wrote. Upward positive, downwards negative we will take. Again you will get same. R minus minus F1 along positive y-axis, along negative y-axis. Same you are going to get. Now F1 d1 is equal to F2 d2. So F1 by F2 is equal to d2 by d1. This is only we will call mechanical advantage. They will say this is about principle of moments. This one and this one you can apply in so many problems. Now how to apply, we will see one or two problems, upward forces and downward forces. So one simple problem we will see, a light rod. Light rod means mass is going to be negligible, of length 1 meter. 1 meter is nothing but 100 centimeters, isn't it? Fulcrum is placed at your wish. It is going to be placed at 40 centimeters from one end. An object is suspended of mass 10 kg at a distance 10 centimeters. 10 centimeters from one end. Then, how much mass should be suspended? They will ask. How much mass should be suspended at a distance? So 80 centimeters or 70 centimeters from one end, they will ask. At the time you will apply this equilibrium condition. Very easily we can do. Just you should come to know what is the distance from fulcrum and how much force is going to act and how that force is going to make rotation clockwise or anti-clockwise. Just if you observe, we are going to get. So for this, we require distances from fulcrum. So if this is the fulcrum, if it is at a 10 centimeters, fulcrum is at 40 centimeters. Can you say what is this distance? So 40 minus 10, that is going to be 30 centimeters. Because we want distances from always fulcrum. What about this distance? This distance is said to be, so from here to here it is 80. So here to here it is 40. Therefore remaining is going to be 40 centimeters. Correct? Now this weight 10g is going to act downwards. This weight mg is going to act downwards. So let us assume it is not there. If it is not there, so this 10g is making this rod to rotate left side or right side. So if this is object means it will be rotating like this. If it is rotating like this means clockwise or anti-clockwise. Now this 10g is rotating this rod anti-clockwise. I told you to take anti-clockwise, positive. Next, this mg, whenever it is not there, that mg is making rotation clockwise. Therefore, so this rotation is going to be clockwise means negative, anti-clockwise positive. I told you take. Next, upward force R is equal to 10g plus mg also we can take. Like that also we can take, but we don't know R. Therefore, we will follow this summation of torque is going to become 0. So whenever required, that one also we will apply. Now we'll see 10g into what is the distance? 30 centimeters. So units also you can write centimeters. So not to get confused. This is positive or negative? Positive. Next, this is negative. Therefore, minus mg. mg is making 40 centimeters. 40 centimeters should be equal to 0. So 10g into 30 is equal to mg into 40. Right side I am taking. If you are getting any confusion, so this one side torque should be equal to another side torques also you can do. So left side one torque should be equal to right side tops. Like that also if you do, you are going to get same answer. Now G will be cancelled. So 0, 0 will be cancelled. Then what is capital M we got? Capital M is nothing but 30 by 4. Isn't it? So 7.5 kg we have to suspend. So this one we have done without taking mass of this rod. If we are taking mass of this rod, how we are going to solve the problem? So that one also we'll see. So next one, uniform rod of mass 500 grams. Now mass of the rod is given. A fulcrum is going to be placed. Total length of the rod is 200 centimeters, otherwise 2 meters. A fulcrum is going to be placed at 40 centimeters. An object is suspended. An object is suspended at 20 centimeters. Isn't it? 20 centimeters I am taking. Mass of the object 2 kg. So another object I am suspending at 160 centimeters. 160 centimeters from this end. Then how much mass we have to suspend to keep this rod at equilibrium condition? So it should be done same like this. Now upward forces how many means resultant force, reactant force are will be acting upwards. Downward forces. One is 2G, another one is mg. In addition to this, you cannot see that one directly, but indirectly it is there. Where it is there means mass of this rod. Where mass of this rod or weight of this rod is going to act means this 500 grams. That is nothing but 0.5 kg. So where is that 0.5 kg is going to act means that is exactly at center. That is going to be mg I am writing. What is capital M? So mass of the rod. So for problem purpose we will write mg, later we will substitute. Now see, if this is the fulcrum is at 40. Now what is the fulcrum to this mass distance means? That is going to be 20 centimeters. If you have taken these wrong, you won't get answer correctly. Next, it is placed at 160 centimeters from one end. Now from fulcrum how much means 160 minus 40. Then what is the distance? 160 minus 40 means this is 120 centimeters. Now where weight of the suspended rod is going to act? Weight of the rod is going to act always at center. Center means if it is 200, total is going to be 100. Therefore, 100 minus 40. 100 minus 40 is nothing but this is going to be 60 centimeters. Just once you understood this, you can get easily problem. Okay. Now see, left side this 2G is converting, is making this object to rotate anti-clockwise. This mg and m is making rotate clockwise. Therefore, these two should be negative, this should be positive. So 2G into what is the distance from fulcrum? 2G is acting at 20 centimeters. This is positive. Otherwise, instead of writing negative, you can write that side. Otherwise, write negative. Negative. Capital mg is acting at 60 centimeters minus small mg. The small mg is acting at 120 centimeters. Isn't it? So this should be equal to 0. You can send those right side. So 2G into 20, all centimeters will be cancelled. Is equal to mg into 60 plus mg into 120. All zeros will be cancelled. All g's will be cancelled. 2 into 2, what is capital M? 0.5 kg. So 0.5 into 6 plus small m we should calculate m into 12. Correct? 4. This is going to be 3 plus m into 4 minus 3, 1. So m into So mass is going to be 1 by 12 kg. Isn't it? So in options, they will give this. So like this, you have to solve the problems. Still, by giving two fulcrums also, they will give. Those we will discuss first. These are the nothing but basics we are applying. So basic problems, if you are able to do, just a little bit logic, more logic we have to apply. Those we will discuss in upcoming problems. So today you can practice this equilibrium condition wherever how many problems you are going to see. Try to do. You will be getting definitely. Thank you.